To solve a radical equation like we have here, we need to start by getting that radical expression on one side by itself. So right now on the same side as the square root we have this other term of plus 3. So we want to move that to the other side by subtracting 3 from both sides. That's going to give us a square root of x plus 3 equals x minus 3. Now in order to undo that square root, we're going to go ahead and square both sides. Squaring that left side simply removes that square root, and so we're just left with x plus 3. On the right side, we need to multiply that entire expression by itself. That's what squaring means. So this is telling us to do x minus 3 times x minus 3. So we'll need to FOIL that and simplify. So we get x squared minus 3x minus 3x plus 9. So again, just still working on the right side there, that gives us x squared minus 6x plus 9. Now we see that we have this x squared term, so this is a quadratic equation. In order to solve this, whether that's going to be by factoring or by the quadratic formula, we need to have a 0 on one side. So we're going to go ahead and subtract x from both sides and subtract 3 from both sides. That way we get a 0 here equals x squared minus 7x plus 6. So this particular problem can be solved by factoring. So we can go ahead and factor this here. We would get x minus 6 times x minus 1. And then setting each of those two factors separately equal to 0 will give us two solutions to the quadratic equation of x equals 6 and x equals positive 1. Now each of those numbers satisfies this quadratic equation that we got to after we squared both sides of the original one. Unfortunately, squaring both sides of an equation does not necessarily keep it equivalent, meaning that we may have introduced an extraneous solution, which is a solution that we obtained without making any mistakes, but that does not actually solve the original equation. And so whenever we're dealing with a radical equation, it's necessary that we check our answers. So we need to check each of these to see if they work in the original equation. So I'll start by checking the x equals 6. I'm going to go back to the original equation and replace the x's with a 6. So I have the square root of 6 plus 3 equals 6. Let's see if we get a true statement there. So 6 plus 3, that's 9. So this is the square root of 9. Plus 3 equals 6. The square root of 9 is 3. And 3 plus 3 equals 6. That is a true statement. So the x equals 6 is a valid solution. Now let's go ahead and check our x equals 1. Replacing x with 1 would give us a square root of 1 plus 3 equals 1. Let's see if we get a true statement here. So this is a square root of 4 plus 3. And that square root of 4 is 2. And we can see at this point this is not a true statement. 5 does not equal 1. So plugging a 1 in for x does not give us a true statement. So x equals 1 is not a solution of the equation. It's called an extraneous solution. But if we're trying to just list the solutions, all that we need to say is x equals 6. That is the only solution to this equation.